It automates the setup of our environments to run a process or like a task, right? So that task can be, starting a website. It could be, running Postgres. Um, it could be a scraper, like we want to make sure that runs and that we can run that on EC2 without worrying about environmental issues. Like that's what we can do that. And so far, what we've done is we've used pre-built Docker images and then like seen how we can interact with them, and we saw how we can, like save the data locally, um, and then also like bind map in so that it can also access some of our local data. We saw how we can obviously like map the ports to our host machine so we can actually use a lot of these services. Um, so today the main focus will just be, okay, like building these images. If you look at, this is the Docker image for Ghost, and, it looks, I would take it like probably fairly complex, but remember Docker's, all it's doing is it's just setting up an environment to, in this case, start up that blogging website. And the way that it always does that when you read these things is that it always starts with the word from, and then after that comes the base image. So this is basically, like the image that Docker will be that this Docker image, the Ghost Docker image, will be starting with. So it'll be starting with an image that has Node, right, which is kind of like a JavaScript equivalent of Flask that has Node installed, okay, and then it needs to build on top of it. So what does it need to do? Well, like it has to basically, install some code here by, getting this GitHub package, set some certain environmental variables here. Here we like make a new directory called ghost install, right? But, when you're looking at this, basically like you can kind of think of it like a sandwich. It always has these three components. One, you're inheriting from a base image, right? You're inheriting from an image that already has some degree of setup. So in this case, we're inheriting from this image that has a node. Two, you're building on top of it, right? And you're basically doing that mainly with this run command. Run just runs, like you do run followed by what you would typically write in bash. So that's step two, is then just build on top of the base image. And then three, this is the command, right? So this is when you call Docker run, when we use this image and call Docker run, what is like the command that's going to be executed. Here the command is, right, like boot up node run this file. Kind of very similar to how we boot up Flask, right? Like we can do Python 3 run the Flask file, right? Or you can do Flask run. So that's essentially the equivalent. So, this stuff, I'd say like there's a couple main points. One is basically you're starting with a base image and then you're building on top of it. And the second thing, this is probably maybe like the bigger point, is that if Docker, all it is just doing environmental setup for us, everything that you do in Docker, like you can do in Bash. It's just automating what you would do through the terminal. So what I recommend doing, we can go through this when you're writing out a Docker, when you're writing out these instructions, is first write it out in Bash, like first try it in Bash, and then from there you can encode it. You can translate it. You can just put the word run effectively instead of your Bash command in front of your Bash command, and and whatever works should still work. So anyway, let's go through it. We can start building a Docker image. The other thing to note is that, okay, these base images, like this doesn't seem like it starts from the beginning because it's like we're starting from installing Node. But remember that this image, if we go to probably like Docker Hub, right? So this is the official image for Node. And let's see, you can probably, one sec. So you can like click, these are all different versions. So Alpine, I believe, is probably some version of, is a version of Linux. Okay, so if you remember our analogy from like the very first lesson of what was there before Docker, right? Um, there was this idea of, and it still exists, right? You have a virtual machine. It's like you install Windows, then you install the rest of the software, right? All until you get to like booting up your website. It's the same thing here, you know? Here we're installing Linux, and then we're setting environmental variable, and then we're just installing stuff, right? And that's this image is then installing Node. And then for Ghost, we're starting with that point of, okay, we'll use that image and then we'll build on top of that. Okay, but you're still starting from the very beginning, which is, which is installing the operating system itself. Okay, right? And notice this itself, there's Alpine 3.8, so it's like, how do we install that operating system? That's what this does. Okay, this has its own image. Cool. All right. Any questions about? I mean, hopefully some of this stuff will be answered. But if there's any immediate questions, let me know. Okay. So let's go through this. What we can do in this case is install. We can install. There's a Docker image for Docker Hub Jupyter SciPy. So we can install the Jupyter SciPy notebook and then build upon that. All right, and so what we can do, and you can see you can explore different notebooks. Here you can see the latest one, and it tells you kind of how to, if we wanted to just use this thing. But for us, what we'll do is we'll try to build on top of it. And basically what we'll try to do is, what is this thing? It's just a Jupyter notebook. You can this is me actually using it. It's a Jupyter notebook. So it just installs Jupyter. And then it also has SciPy, which means like it has certain libraries, right? Certain like Python libraries like pandas, scikit-learn, other libraries already installed for us. So that's all it is. All right. So if we want to, say, not only like have an image that sets up a Jupyter notebook, but then also, let's say, installs like a certain library added onto it, that's what we'll do. And so we'll set up this notebook, and then we'll also install the Kaggle. Kaggle has a nice like library that allows us, if you remember Kaggle, right, it like allows you to work with data sets, submit like these data science competitions. So Kaggle has like a tool that allows us to like quickly download various data sets from Kaggle. It's just a Python library. So what we'll do is we'll start with this Jupyter SciPy notebook, and then we'll install the Conda library, and we'll build an image that basically sets up this Jupyter SciPy notebook with with Kaggle's library installed on it. So here's how we'll do that. So I have we may even move. Yeah. So I have this Jupyter Kaggle folder. I spelled it wrong. Let's move it to be Jupyter Kaggle. Spell it right. Then we can cd into it. The first step is we'll create our Docker file. Okay. So it's capital D, and then everything else is lowercase, and it's all one word. And this is like you should, unless you do some other configuration, type, this does matter. It will be looking for this file. All right. And then think about like how we, if you look at our ghost image, what do we start with? We start with from and then our base image, right? So for us, it would be from and then our base image. Okay? And if you want, we can just start with the command. And the command is probably, it's either Jupyter Notebook, or like, I don't know if you could use Jupyter Lab. It's possible. Yeah, we'll just do Jupyter Notebook. So we won't even build on top of it for now. Okay. So one thing to note, right? This is the command. So we'll build this, and then this is the command that will be, started when we do Docker run. Okay. So the next thing we can do is, so you can take a look, right? We have this Docker file. We can do Docker build dot. The dot just means the current directory, like it always does in Bash. If we build this thing, okay, so this is building. It's just basically one step. So the one step is to use the base image essentially, and you can see that it's kind of saying that loading the data for Docker Jupyter SciPy Notebook latest, right? So it's using that base image, and then it's writing this image, right? Exporting the layers, writing the image to here. If you take a look at the Docker image ls, one thing that's annoying is that you won't see it. I mean, I think this is the one. It says it probably just didn't recreate it because I already had something similar on it, but you won't see the name. It's like, how do we refer to this image that we just built? We just did Docker build dot, and it will give it an image ID. So it's whatever this is. Do we see it anywhere? 90. Let's see. But it's one of these image IDs. But you can see already, it's just so annoying not to know the name of the image. So normally what you'll do is you'll tag the image. All right, so let's do that. So just do Docker build -t to give the image a name, right? And then we can call this, I can call it, I'll just call it Kaggle image. All right. Okay. So now, naming to Docker file library Kaggle image, it did the exact same thing as before, just like installs this. Now if I do Docker image ls, right, it should be there. Oh, there it is, Kaggle image. Okay. Cool. All right. So how do we run this thing? We have to do Docker run, right? And then we'll do Kaggle image. What will happen here? So now you can start to understand why is it performing this process. Is doing that because the last line, let me just shut this down. The last line in our Docker was to run this command, was write command Jupyter Notebook. So that's all it's doing. So you can see I'll talk about that in a second. All right, so what should I do here, right? This obviously isn't going to work because I did not map the ports. So let's do that next. Let's just do -p 8899:8888, right? So it's going to run on 8888 by default, and we'll map that to 8899. And then let's click on this. Cool. All right, so you can see we have Docker running. What is kind of interesting, so maybe we'll go through it now. Let's go through my recommended way, which is we can do Docker PS. So this is what's running, this Kaggle image. This is the name of the image. Is that it? Flamboyant 2? Yeah. Okay. And now the next thing we can do is work through do our environmental setup through Bash, and then encode that in our Docker file. Okay, so Conwell asked a question. Okay, you have done here, so far, so what we'll do is Conwell asked, we'll do this for Kaggle. If we had a file like requirements.txt, how do we install all those dependencies in the Docker file? Yeah, so we'll go through that, Conwell. We will install, I'll have you install Flask and things like that. So we'll get there. So let's exec into this container. So Docker exec -it, right? It's exec because it's we're issuing a command to a container, right? And then we'll do bash. Okay, so now I'm in this guy. All right. Now what I want to do is I want to first install Conda. So I can do Conda install Kaggle, right? So this is like, and I just want to go through this in the shell first and make sure it runs. Like make sure this is effective. So this should, so you can see it's starting to do this. I'll save the suspense. This will end up working. We'll check it to make sure. But now that this looks pretty good, we can just now encode this in our Docker file. So now we can start to fill this in, right? So do run conda install Kaggle. I'm pretty sure this, yes. There is a way to, if you get stuck here, like you see how I have to type in the letter Y. There is a way, if we get stuck here, that it's like, how does Docker know to type in the letter Y? I don't think it will get hung on this, but if it did, there is a way to like automate it saying yes too. So you can see this works successfully here, and now we encoded it over here, right? So it's like, all right, we did this step, let's write out that step, okay? I always do that, don't I? Okay, and now what do? You will need to rebuild the image, right? If you just do docker run, whatever it was called, image Kaggle, let's say docker image ls, docker run Kaggle image. If you just did that, that's not going to do it, right? You're going to, every time you make a change in your Docker file, you're going to have to rebuild the image, okay? Because it's not looking at your Docker file. It's looking at the built image when you call docker run, okay? So do the same thing. I'm just going to press up a few times until I get, it doesn't look like I'm going to get there. So do docker build, right? Docker build the build context. I'm in the wrong, so I'm saying the build context, but I'm not in the right folder, sorry. So docker build, this dot, right, again, it's going to look for the current, this means it's going to look in the current directory for this Docker file, okay? So docker build dot, and I need to do -t, and then I just want to make sure I keep the same name. So docker image ls, sorry, I keep doing this. It's called Kaggle image. So I'm just going to give it the same name, Kaggle image dot. Okay. So now notice what's happening. Okay. The first step is the same, SciPy notebook. Second step, run conda install Kaggle. And then you can see the same thing that was occurring in our container is now happening. Collecting metadata, right? We saw the same output. Solving the environment. So it's setting up the image, building our image by basically just performing the exact same steps. Okay, so Narapati says, hey, both run and command execute shell commands. What is the difference? Like, why are we using run and not using command? Command should be is always the last. If your command, right, is going to set up what gets run when you call docker run, when you actually build the container. Okay, so you can notice something. The run is occurring now. Like if you look in the image, that run, we have installed Docker, and all those packages are now packaged up. They're saved to disk. This step, however, has not occurred, right? So notice there's only two steps here. So step one was building downloading this. Step two was installing Kaggle. Step three did not occur yet, right? The reason why is because step three only occurs when you do each time you boot up a container. So the command indicates that this is the command that will be run when you boot up a container. Run operations will be run when you're building the image. So first you build the image is saved, then you do docker run that image, that will execute this. Yeah? Cool. All right, so now we do docker run -p 8899:8888. Then the name of so I'm mapping the port, and we'll do Kaggle image. So we'll boot this thing up again. We can look at it. it's, we do see some sort of error here, but it's all right. So we should go to 8899. And now if we click on that, we try to interact with this thing. We can try to use Conda, right? Remember, I can access something from here. And, I did not expect this to work so easy. Well, this is Conda. Sorry, we want to do Kaggle. Okay, this is the error I was expecting. Right, so first of all, we installed the Kaggle package. All right, it is kind of working. It says from CLI, right, opt conda bin Kaggle. So this is the Kaggle package is there. But now it says could not find the Kaggle.json file. Make sure it's located. So basically, what we need to do is we need our API keys to interact with Kaggle. So this also just gives us an excuse as to understand, okay, how are we going to get API key, how are we going to get our API keys in this container? So the way that you get the API keys from Kaggle is you can go to your profile. I think it's here, and then it's settings, and then from here you can just create a new token. All right. So I already did that before class, but the issue. So here it's inside my notes folder. So I'll move it kaggle.json to the current directory. The issue is that I need to somehow get this file. You can kind of see the error message. Right? It's saying, hey, this file needs to be in the container, in a folder. Let me just show you. Am I not running it? It needs to be in this docker exec -it bash, right? What it was saying was it has to be in the /home/jovian.kaggle folder. Okay? So how do we do that? Well, again, kind of the trick to all this stuff, basically, is to just do it in bash first and then, translate it, encode it in your Docker file. So the next step would be make a folder, right, called makedirectory.kaggle. Make sure that works. Do ls-a. Now we have that folder. Okay? So let's do the next step. Let's go back here. We can do run makedirectory.kaggle. Okay? Now here's going to be the hard part is the file's located on my host machine, and somehow I need to get it in my container. So this part we have to actually shut this down and show you what we'll do. So Docker has this command called copy, and we'll say we're going to copy. And remember, in Docker, it's always host to the image or container. All right. So in this case, we're going to copy this file. I think I should probably do this /kaggle.json to the folder in here, which was /home/jovian/.kaggle, right? /home/jovian, right? /.kaggle. So this is a new command now, all right? And the way that it works is you specify the file or folder that you want to copy, where it's located on your host machine. Okay, so this is located here. And then you specify where you want it to go. All right. And then we'll rebuild, and we'll see if this worked. And we can, I can go through, there's a couple details we can fill in about this. So the name of the thing is, I think Docker image Kaggle, but I'm never quite sure. Kaggle image. Okay, so do Docker build -t Kaggle image dot. Okay, remember this is what's called, this dot is the build context. It tells you where the Docker file is located, right? So the Docker file is located here. But then also, now let's take a look at the steps. We ran Kaggle install. we did make the directory .kaggle, and then we copied ./kaggle.json into home/jovian/.kaggle. So let's just first make sure that this worked, and then we can fill in a little bit more about how this worked. So we can do docker run kaggle image. I think that's right. Did I call it right? Yeah, kaggle image. And then let's do the -p is fine. 8899, 8888. We didn't even have to do that. And then we'll what we'll do next is we'll let's take a look at this thing. Let's exec into it. Docker exec -it, the name of the container, bash. All right. Now if I do ls-a, here's that folder, right? And that came from my Docker file, from when I built the Docker image. The next thing I said I did was I copied the kaggle.json file. So let's take a look if that's in there. Let's cd into .kaggle. And then you can see there's the kaggle.json file, right? It has, my API keys are in there. Okay, so that was pretty good. So now if we'll probably run into another error. In fact, I'm pretty sure we will. But still, we're making progress. Let me just click on this and make sure. And this is really just how you go about this, right? Like I said, the main point is do this in bash for exec into our image, right? Go through the steps in the image, exec into your container, go through the steps there, and then encode it in your Docker file. I was not doing this when I was prepping for this lecture, and I ran into an error, and it wasn't until I took my own advice that I solved it. So now if you look at .kaggle, this will be good. Okay, so we do get a warning. I'm not sure the readings go through how to solve this, but before moving on, we can go into that copy command again. Okay, is home/jovian automatically created for Jupyter image containers? Yes, right. So when and you can kind of see that when you sh in there. Not only can you see that home/jovian is there, but you can see it's important to kind of take note of what is the current working directory. It's setting up that this is the directory we want you to be in when you boot up the container. Okay, cool. Let's look at the copy command again. I just want to show you something about it. So a couple things to note. We are copying, this is a relative file, right? This is a relative path that I'm specifying. So I guess the question would be how does Docker know from which starting point, where we're starting from on my host machine? And it's starting from the build context, right? So this dot is where it's starting from. This dot indicates when you say copy from the relative ./kaggle.json, it's because we're saying we're in this folder and we're saying from the current directory. If we did ./notes, that's my build context, it's going to break because there's no Docker file in there, and also this kaggle.json file is not there. You see this? Trying to do it, failed to read Docker file, no such file or directory. Okay? So you can specify a different build context, but this is kind of the typical thing, right? So it's this kaggle.json, we're able to specify something relative because it's relative to the build context. And then this is an absolute path, but this actually doesn't, we can, I will show you one more command on top of, beyond this. This is very good. If you understand this is really good. So let me just review for a second and then give you an opportunity to ask questions before we show you one final command. All right, so this is from Jupyter SciPy Notebook. This is our base image. run, right? This is just literally doing what we would do in Bash. We're installing a package, right? So we just put the word run in front of it. Make directory, we all know what this does. And then the copy command, copy from my host machine to the image. All these get run all these get performed when you do Docker build, and this one's saved for when you actually run the container. In Docker, so the question is, in a data engineering role, what would you say is the most common use case for Docker? Basically, this will encapsulate like your code, so all the different techniques that we've been doing can be encapsulated by Docker. So what would be an example of this? Our Flask API, right? We need to build a Flask API. We need to update it. Chances are, like in most organizations, that Flask API will be built as a Docker image, and you'll have to run it. Okay, Streamlit could be a separate Docker image, a scraper, right, or something that just a scraper would be a separate Docker image. For some of our internships already, every task that you run in Prefect, like let's say it's like hit this API, save it to Postgres, right? That task of hitting these various APIs are packaged up in an image. So it's possible to be in some workplace environments where everything will be in Docker. Yes, it's very possible. Yeah. Right? And so that's kind of why we teach this, is because while I don't see this asked so much on interviews, people will certainly respect this in your code, because it shows that you're able to work in their workflow, which will be using Docker, right? More typical on interviews will be, what is Docker? Why is Docker used, right? So I'd say something to practice would be answering that. What is Docker? Docker automates the setup of our environments to run a specified task. And then you can, right? So that's the answer. Then you can go into some examples, right? And that could range from that task could be running an API. That task can be, running a scraper. But the benefit of that is that when we build something in development and then deploy it to production, right, that we can have more assurance that the same environment we have in development, or very close to the same, will be replicated in production. Not only that, but if we're working across a team, right, that environment will be replicated, right? We'll have consistency across each of the developers in that team, right? And that way we know that code that works on my computer will work on theirs, etc. Right? So that's kind of what people will ask about. But sometimes for your take-home project, if they give you a take-home, they'll ask you to do this too. But more it's on the job in your internships. Yeah, people use Docker all the time. Okay, one last command. That is work directory. So remember when we do Docker build, I kind of was telling you this, and then we do this Docker exec. Let's run it. Actually, we can even do this. Remember, I can run and specify the Kaggle image, and then if I want to, I can override the default command, right, which is to run Jupyter Notebook by just doing bash, and I'll still need to do the -it to make it interactive. So notice where we are. We're in this folder, home/Jovion. It's why are we in that folder? Something like that is also specified in the Docker file. So in this case, it was probably specified in one of the base images. But what we can do is, if we did something like this, so notice we have made this folder .kaggle. If we do this work directory, no, is it? Oh, it has an R, oh no, in there. Work directory .kaggle. This will change the current working directory. So it does two things. One is it will create the .kaggle directory if it does not exist. And then two, changes the working directory, where we are. It's basically effective to cd into .kaggle on your image. Okay? So what does that mean? That means if I do this, and then I'm copying the Kaggle file, I just copy it to the current directory, because the current directory is .kaggle. So here I'm installing, if you think about it, here I'm in /home/jovian/work. Here I'm creating this directory, and I probably will be in home/jovian/work/kaggle. And then when I copy, this will copy my Kaggle JSON file on my host machine to this, and then I can, I think at that point I'll probably cd out of it by doing working directory ... right? And that'll take me out of Kaggle back to here. And then I'll be done talking, or I won't cover any more beyond this. Let's just see if this works. I'm not sure. And I just show you this because you're going to see it and because it is useful. Docker, right? So we specify this. Ooh, that worked better than I thought. So notice this step, right? Working directory .kaggle, copy kaggle.json, working directory ... So just remember, kind of like, this is creating the Kaggle folder. It's then moving this file over to the current directory, right, which is this Kaggle folder. Then we're changing the working directory back to /home/jovian/kaggle. Let's boot this up. So we'll do docker run Kaggle image. Is it Kaggle image? Yeah, Kaggle image bash -it. So which directory should we be in? Right, we should be in this one, because we first we're here and then we cd'd out of it. So let's take ls. That looks right. Home/jovian/work. Then if we do cd into .kaggle. So first of all, notice this folder exists. Why does it exist? Because this will create it if it doesn't exist. And then notice this file's in there. Why is it in there? We copied into the present directory, but this effectively was like cd into .kaggle. So we copied the file into the present directory, then we cd'd out of it, and then we booted up our container. Okay, so that's why when we got into here, like the state of the image was that this home/jovian, right, was the directory that we'll always be starting with. If we didn't do this, notice what will happen if we don't do this. Well, I'll just rebuild it just to show you for fun, because I know we are enjoying this. Look where we are in the .kaggle folder, right? That's where we're starting up, right? Why? Because we are setting this as the present working directory, and we never changed out of it. Okay, so again, we need to rebuild every time. Docker build, Docker run, and now with me cding out of it, right, now we're back in this folder. Cool. All right, that's basically it. There's one last thing. This is going to drive you crazy, just for fun. If you do single quotes instead of double quotes, it's just so great. Let's do Docker build, unless they fix it, but I doubt it. Docker run Kaggle image. Okay, what a beautiful error message for a totally obvious reason. Bin bash line 1 Jupyter whatever command not found. This actually is almost readable, like if you squint. What's happening is it's not parsing. You can see it's Jupyter comma, because it's not parsing that there's a separation between the arguments in the list. Okay, so that's why it's still going and then it breaks, right? So the whole point is, and this is, I had to go through this, if you put in, the way that we put in the command is that it's a list, okay? Whatever you would type in bash, you just separate each word with a comma. They'll just become the elements of the list, but they have to be in double quotes. If you do single quotes, you'll get that weird error message, right? You'll get this. Okay, so rebuild it, and then run it, right? And now we don't get that error anymore. Okay, cool. All right, that was a lot.